Hi, it's Mrs. Moss here, and today we're going to start talking about stars and the way they form and their life cycles. So stars form from huge clouds of gas and dust, which is considered a nebula. Gravity causes the gases to condense, and as it condenses and becomes compressed together, the temperature and the pressure will increase, leading to nuclear fusion. Now, the star is considered born when it starts to fuse the hydrogen that's existing and turning it into helium. And that's what gives off the energy that we see and the shine. Now, there are many different types of stars, and it really depends on what stage of life the star is in to give it its classification. The star types are main sequence, blue supergiants, red giants, white dwarfs, and red dwarfs. Most stars are in the main sequence stars for the majority of their lifespan. Our sun is an average size star, and it's a yellow star. Let's talk about star formation. All stars begin as nebulas. I used that word before. A nebula is the gas and dust molecules that are swirling together. A nebula is considered a star nursery. This is a really cool picture of an eagle nebula. They call it that because they think they could see an eagle in it. I don't know. Can you see an eagle in this picture? Star evolution. A star will live out most of its life as a main sequence star. Eventually, it will start to exhaust its fuel supply. So it'll burn off that hydrogen and it will then die out. Stars can take one of two paths depending on its mass. So let's look at the two paths that the cycles can go through. Now, if it's all stars start off as a star nebula, as you can see in this picture all the way on the left. Now, depending on its mass, it can either follow the path of an average star or the path of a massive star. And we're going to talk more about each of those paths in the next few slides. Here's another diagram of how stars begin as star nebulas and then can become two different types of star depending on the mass. So the first path it takes, the path that we see as stars similar to our sun, it begins as a nebula, then turns into a main sequence star. Then it will expand in size to become a huge hot red giant. Once it burns off all that hydrogen and starts to then collapse to form a small hot white dwarf. When there's no more nuclear fuel, the star will cool and no longer produce energy or emit light. That would be this phase of the black dwarf, or we consider that a dead star. Stars that are considerably more massive than the sun will expand into a supergiant. When the stars then completely exhaust their fuel supply, the outer layers explode actually and get larger into a supernova. The core then will rapidly collapse into a super dense neutron star. Sometimes, though, when those extremely massive stars start to explode and the core collapses, the density becomes so large that it becomes this humongous gravity field, and it becomes it gets to a point where energy cannot escape. So that is what we call a black hole, where it's a massive gravity that surrounding by a lot of light and energy, and it just can't leave that area because there's so much gravity holding it in. Let's look at some star facts. The larger stars have a shorter lifespan because they burn up their fuel faster. The sun will live out its life as a main sequence star and will eventually become a white dwarf and then a black dwarf. Only massive stars explode into a supernova, and even fewer become black holes. This is a picture of a supernova taken by the Hubble telescope. We get a lot of our images of stars and nebulas from the Hubble telescope. And we're going to end right here for now. You're going to continue learning about stars in our next video. I hope you have a great day, and I hope you were able to get down all those notes. Hopefully you were pausing and you're going to rewind and go back as you need to. Take care.